Welcome to the deep dive. Today, we're jumping into something that's really changing the game. What it actually means to be an AI engineer in 2025.
Yeah, it's huge. AI isn't just theory anymore, is it? It's getting woven into, well, pretty much everything. How businesses run, our daily lives.
Exactly. And the AI engineer, they're right at the center of it all. Absolutely critical.
Definitely. And we've pulled together quite a bit for this detailed notes, looking at how the role's changing, what defines it, even a kind of study guide for the skills needed.
All right. So the plan today is to really get a handle on this 2025 AI engineer. We want to map out how they're different from, say, a data scientist or an ML engineer.
Yeah, nail down those key skills.
And look at the really exciting trends shaping what they do. Think of this as your shortcut to understanding this really key area.
Let's do it.
Okay, so let's start right there. Fundamentally, what is an AI engineer now in 2025?
Well, what's really interesting is how distinct the role has become. It's not just lumped in with data science or ML engineering anymore. I mean, sure, there's overlap in the skills, but the AI engineer has a much, much wider brief now.
Wider? Wider how exactly?
Well, it's not just about building the models.
Yeah.
That might be more the ML engineer's focus. The AI engineer, they're looking at the whole life cycle,
The whole thing.
pretty much. From the initial idea, the design, actually building and training the models, and then this is key, deploying them, getting them out into the real world.
Okay.
And it doesn't stop there.
Yeah.
They're also handling the ongoing operations, making sure things run smoothly, integrating the AI with other systems, optimizing performance, security, making sure it's all above board,
Yeah.
ethically speaking.
Wow. Okay. So they're taking the insights from data scientists, the models from ML engineers, and actually turning them into robust working systems.
Yeah, exactly. They're the bridge. They connect all those different stages. And that means collaboration is, well, it's non-negotiable.
Right.
AI engineers in 2025, they're deep in these multidisciplinary teams. You've got data scientists, software devs, people who really know the specific industry.
Domain experts.
Domain experts, yeah, and business folks too. Everyone working together.
Makes sense. You can't build, I don't know, a good medical AI without doctors involved, right?
Precisely. And the demand. Our sources are really clear on this. It's incredibly high and still growing
Across the board.
across so many sectors.
Yeah.
Healthcare, finance, e-commerce, manufacturing, cars, entertainment, you name it. And we're also seeing this need for industry-specific knowledge becoming more important.
Ah.
Like, the core AI skills are great, but really understanding how AI works in finance versus how it works in manufacturing, that's becoming a big advantage.
Okay, so a broad role, high demand, needs collaboration, often industry-specific knowledge. Got it. Let's talk toolkit. What are the absolute must-have foundational skills for 2025?
Okay, foundationally, strong programming skills, still paramount. And Python, still the king.
Still the main one, huh?
Oh yeah, the libraries, the community, it's the cornerstone for AI development.
But I saw in the notes it's not just Python anymore, something about polyglot programming.
That's right. Python leads, but knowing other languages, increasingly valuable, gives you flexibility.
Like what?
Well, think R for stats and viz, C++ when you need raw speed, like in robotics or real-time stuff. Java's still big in large companies, enterprise AI.
Uh-huh.
And Julia's making waves, especially for high-performance computing, some ML tasks. Oh, and SQL. Can't forget SQL. You need it for getting data out of databases, which is, step one.
Right, data wrangling. So Python's home base, but fluency elsewhere is a big plus depending on the job.
Okay. Makes sense. What about the math? AI always sounds pretty math-heavy.
It can be, yeah. And having a solid math grasp is indispensable. The notes point to a few key areas.
Go on.
Linear algebra, that's fundamental for how data is structured. Vectors, matrices, tensors, all that stuff that underpins ML and deep learning models.
Like how images are grids of numbers.
Exactly. And linear algebra gives you the tools to work with those grids. Then calculus, crucial for model training, optimization, like gradient descent.
Probability and stats, essential for uncertainty. Model evaluation, making predictions. Optimization theory, more broadly, finding the best settings for algorithms. And graph theory is popping up more for relationships in data, even understanding neural net structures.
Okay, solid math needed, got it.
Yeah.
Moving up a level core machine learning concepts. What do AI engineers need a firm grip on?
Yeah, they need the main paradigms down cold. So supervised learning, first learning from labeled data. That's your classification, predicting categories, and regression, predicting numbers.
Right.
Think linear regression, decision trees, SVMs, random forests, that kind of thing. Then unsupervised learning, finding patterns in unlabeled data.
Like clustering.
Exactly. Clustering, finding associations, reducing dimensions, k-means, PCA, stuff like that. And of course, reinforcement, learning through trial and error, rewards and penalties.
And it keeps changing, doesn't it? The notes mention newer areas too.
Oh, for sure. Semi-supervised learning, using a mix of labeled and unlabeled data, and self-supervised learning, where the model learns from the data's own structure.
Hmm.
Both are getting pretty important. AI engineers need to be aware of them, definitely.
Right. Okay, deep learning. Feels like that's powering so much of the AI buzz right now. What's essential there?
Deep learning is absolutely foundational now. You need the core architectures.
Hmm.
Basic artificial neural networks, deep neural networks, the building blocks,
Hmm.
and convolutional neural networks, CNNs, vital for images, video, computer vision workhorses, recurrent neural networks, RNNs. They were for sequences like text, time series.
Hmm.
But like the notes say, they're kind of being overtaken.
By transformers.
Exactly. Transformers have, I mean, they've really revolutionized sequential data processing, especially NLP.
Oh.
It's this thing called self-attention. Lets them process stuff in parallel, handle long-range dependencies way better than RNNs. That's why they're behind all the big, large language models, the LLMs. Understanding transformers is non-negotiable for an AI engineer now.
Wow. Okay, so it's a huge knowledge-based theory, practical coding. What about the actual, like, day-to-day tools? What platforms and libraries are they using in 2025?
Right, the toolkit. It's pretty extensive for deep learning, model building, training, TensorFlow, PyTorch, Keras. Those are the big ones.
Standard stuff.
Yeah. For more traditional ML, scikit-learn is still everywhere, handling structured data. Gradient boosting libraries like XGBoost, LightGBM are super powerful.
Okay.
Then for specific areas like computer vision, you've got OpenCV. For NLP, Hugging Face Transformers is massive, plus NLTK, Spacey, and underlying it all, you need pandas and NumPy for just handling the data.
And running all this
Yeah.
takes some serious horsepower, right?
Oh, absolutely. Cloud platforms, AWS, Google Cloud, Azure, they're basically essential now. They give you the scale, the specialized hardware like GPUs, TPUs,
And the MLOps tools.
and increasingly integrated MLOps tools. Exactly. Knowing your way around at least one major cloud provider is pretty much a core requirement. And yeah, data handling skills, cloud pipelines, SQL, maybe even real-time streaming data. Super
Yeah.
important.
Okay, we've talked building, training, but actually deploying these things, making them run reliably in the wild, that seems like a whole challenge in itself. That's the MLOps piece you mentioned.
Exactly right. MLOps, machine learning operations. It's absolutely critical for actually getting AI systems working properly long-term.
So what is it, really?
It's basically applying DevOps ideas, rigor, automation to the whole machine learning lifecycle. Automating the pipeline, CI/CD, but also CT, continuous training,
Ah, okay.
plus monitoring models and production, governance, versioning, making sure experiments are reproducible. It's about getting models deployed faster and stopping them from degrading over time model drift.
So it's making sure AI isn't just a lab project, but a production-ready, scalable, maintainable thing.
You got it. And tied into that, you absolutely have to talk about responsible AI.
Right, the ethical side.
It's not just a nice to have anymore, it's fundamental.
Yeah.
Ethical development, fairness, transparency, accountability, privacy, security, reliability.
Yeah.
These have to be baked in from the start.
How do you ensure transparency?
That's where explainable AI or XAI techniques come in. Methods to help understand why a model made a particular decision. Crucial for building trust and for debugging.
Makes sense.
Hmm.
Okay, looking ahead then. What are the big trends AI engineers need to keep an eye on? The field moves so fast.
Incredibly fast. Well, generative AI and LLMs are obviously huge and still growing. They're moving out of the lab and into real products everywhere. Engineers need skills to work with them.
Definitely.
Then there's multimodal AI systems handling different data types together, like text, images, audio, that's leading to richer applications. And AI agents are getting big too.
Agents, like autonomous systems.
Yeah, systems that can perceive, decide, and act on their own to reach goals. Think sophisticated chatbots, robotic process automation, that sort of thing.
What about processing closer to the data source? Edge AI.
Yep, edge AI or edge computing.
Yeah.
Gaining a lot of ground. Good for low latency needs, privacy, efficiency, less data flying back and forth to the cloud. So engineers need skills in optimizing models for smaller devices. Quantum machine learning is worth a mention, though it's still mostly research-focused, exploring quantum computing for AI. And XAI, explainable AI, we mentioned. Its importance is only growing.
Right. Now, the notes also talked about a shift towards data-centric AI. What's that about?
Yeah, that's a really significant shift in thinking. For a long time, the focus was mainly on tweaking the model architecture.
Better algorithms?
Right. But data-centric AI recognizes that often the biggest gains come from improving the data, the quality, the quantity, the labeling, the management of the training data itself.
So focus on the data, not just the model.
Pretty much. It acknowledges that in the real world, the data, its biases, its gaps, its weird edge cases, is often the bottleneck.
Okay.
Teams are finding they get better results by really curating their data sets than by endlessly tuning the model.
Which leads nicely into synthetic data, right? That's becoming more important too.
Exactly. Synthetic, artificially generated data is becoming vital when real-world data is hard to get. Maybe it's too expensive, or there are privacy rules, or just not enough edge cases. So AI engineers increasingly need skills to generate this synthetic data and use it effectively, especially in fields like healthcare, finance, self-driving cars, places where data is sensitive or scarce.
Oh, okay. So loads of technical skills. But what about the people side? Soft skills. Are they important for AI engineers?
Oh, absolutely crucial. Maybe even more so as AI gets more integrated. Technical skills get you in the door, but soft skills make you effective.
Like what specifically?
Communication is huge. You have to explain complex stuff to people who aren't technical experts. Problem solving, critical thinking goes without saying, right? Adaptability, the field changes constantly, so you need to love learning.
Continuous learning, yeah.
Totally. And domain knowledge, knowing the industry you're working in, that's becoming super valuable.
In career paths, what does that look like for someone starting out or wanting to grow?
Well, typically you start more junior, right? Learning the ropes, working on specific parts of projects. Then you move up, senior roles, maybe lead roles, taking on more strategic stuff, system design, innovation.
Specializations too.
Yeah, definitely. You can specialize in computer vision, NLP, robotics, AI, MLOps, or even lean more towards research. And the notes mention getting high demand skills, relevant certs from AWS, Google, etc., that can really boost your career and earning potential.
So lots of routes.
Lots of routes. And tons of resources to learn online courses, certs, uni programs, conferences, open source projects. The main thing is having a plan, your own roadmap, and just keep learning.
Okay, so wrapping this up, it really sounds like the AI engineer in 2025 is this incredibly central, pivotal role. It needs a super diverse skill set, deep understanding of the whole AI lifecycle, and has to be ready to adapt constantly.
That sums it up perfectly. It's demanding, yeah, but also incredibly rewarding work, I think.
So a final thought for you listening. We've talked about all these trends, generative AI, data-centric AI, edge AI. Which one do you think will shake things up the most in your world, your industry?
Yeah, maybe based on our chat today, what specific skill or area feels like something you might want to dig into a bit more?
Good question, because staying informed, keeping that learning muscle flexed, it's just essential in this field.
Absolutely vital, no matter what you do.
Well, thanks for joining us on this deep dive into the AI engineer of 2025. We'll catch you on the